All right, welcome to Unit 13 Review Part 1. Let's dive right in. First thing we're going to talk about is the monopoly, mainly their characteristics and then how to graph it. Okay, so the characteristics of a monopoly are that one firm is the market. That's the idea. That's the mono part of the monopoly, right? One firm is the entire marketplace. There are no other goods like it out there, and that's the second characteristic. It's a unique product, right? No close substitutes out there. Really high barrier to entry. This is why no other firms are competing against them in this marketplace, right? Because it's really difficult to start your own business in the market. First reason is just enormous economies of scale for the monopoly, right? They have a huge advantage over you. You have to build out all the infrastructure to compete with them. Government licensing is another huge barrier to entry that could exist. So, for example, if they have some sort of patent on a technology and there's nothing you can do to compete with them because you can't copy what they're doing. And then pricing advantages, right? When they buy things in bulk, buy millions and millions of gallons of milk, for example, they get a discounted price on that. When you're a small business just starting up, you're unable to get those same benefits. So as a result, really difficult to enter. So this monopoly, if unchecked, will continue to be just a single entity or a monopoly, unless we try to break it up through government regulation or add price ceilings if it's a natural monopoly. And then for a monopoly, they have to advertise, right? So they advertise not a ton, not as much as monopolistic competition, but they do advertise because if demand shifts right, if people want more of their product, then they're going to see an increase in profitability. Okay, so what's this look like on a graph? Over here, we have a graph, so you can see it highlighted right there. But it's only one graph. Remember, in perfectly competitive, we had side-by-side graphs. We had the market and we had the perfectly competitive. Well, now we only have one graph because the market is the firm, right? They're the same thing, one and the same. So we got our one graph right there. Cost curves are the same. We have our ATC going down, going back up. We have our marginal cost with our little swooshy thing going on there. Then we have demand as a downward sloping D, and then we have marginal revenue, which is less than that. Notice that marginal revenue and demand are not the same, right? Marginal revenue is less than demand, and that's because monopolies are unable to price discriminate, right? For the most part, they're unable to price discriminate. The reason monopolies can't price discriminate is because if they want to attack the marketplace, they have to lower the price, not just for one, but for all. So what's that look like? Well, you see right here as zero, quantity of zero, at $11, nobody's going to buy it. So in order to attract people to the market, even in a monopoly, they still have to make sure they're charging a price people are willing to pay. Right? I still can't compel somebody to buy something from me in a monopoly. So if I want to sell the second unit, I take this down to $10, or the first unit, sorry. I go from 11 to 10. When I get to 10, I sell one. My total revenue is 10, right? Price times quantity, 10 times 1, 10. My marginal revenue went from 0 to 10, so my marginal revenue is 10. Look at the next one. In order to sell the second unit, I have to lower it to $9, right? Well, when I lower it to 9, I can't charge the first person 10, the second person 9. That's price discrimination. That's not allowed. So my total revenue is going to be 9 times 2, or 18, right? Instead of 10 plus 9, which would be 19. So it's going to be 18. And so my difference is 10 to 18. My marginal revenue is 8. So notice my demand curve here, the first column, went from 11 to 10 to 9. This one went from nothing to 10 to 8. If I go to the third one, it's $8, right? I get 3 people buying it. I can't price discriminate. Can't charge the first person 10, the second person 9, the third 8. I have to charge them all $8. So 8 times 3, or 24, is our total revenue, right? Price times quantity equals total revenue. My change in total revenue, which is marginal revenue, goes from 18 to 24. So my marginal revenue is 6. All of this to say, as you track this all the way down, marginal revenue is going to fall. It's going to start at the same right here, right? Start at the same, but it's going to fall at a quicker rate. It's going to be beneath our demand curve, as we see here. Here's demand curve, and there's marginal revenue, starting at the same point, but decreasing at a greater rate. Okay, so that's how you graph it. Marginal cost, average total cost, demand, and marginal revenue are separate. That's the big change right there. Now, also, whenever you're doing this, remember that you're still going to have the profit maximizing rule, right? Right here. MR equals MC is still where profit is maximized. So I'm still going to produce a quantity, a little pin up there. right here where MR equals MC. So my quantity I produce is QM. But that's not the price that I charge, right? I'm able to charge a much higher price, which I find up here at the demand curve, because people are willing to pay PM, not this very low price, right? I know they're willing to pay it because demand indicates that to me at that quantity. At that quantity, they're willing to pay this higher price. So I sell it at that higher price right there, okay? So that's the general way that you graph a monopoly. Let's start from scratch on this next one and see if you can figure it out and calculate total revenue and total cost. All right, whenever we're doing this, first we find our profit maximizing quantity, which is where price, and we find our price at the demand curve. So here, our profit maximizing quantity is where MR equals MC. Always, always, always is. All these market structures are the same, right? So I'm going to produce at a quantity of 6, but I'm not going to charge this low price of what, like 450 there. I'm going to dash all the way up because price equals demand. I dash up until I hit the demand curve. That's going to kick out a total price of 6. Now, and so instead of charging 450, I charge 6 because people are willing to pay $6 at that quantity, right? I know that because that's what demand curve indicates. How much are people willing to pay at a given quantity? All right, so we got that so far. Now we need to find our total revenue. Total revenue is price times quantity. So 6 times 6. So our total revenue is 36, or it's represented by this large box here where we go from 6 to this dot to this 6 to the 0. That big old box there is going to be my total revenue. Then I have to find my total costs. Let me change colors here. On my total costs, I take my from the quantity of 6 all the way up until I hit ATC. That's right there. I dash over. My total cost is going to be 5. So it's average total cost times quantity. So it's 5 times 6, or 30. And then I find my profits or my losses. So here I'm going to have profits. My profits are the distance between my total revenue, big box, total cost, little box. So this rectangle right here is going to represent my profits. Or it's going to be 1, distance between those two, 1 times 6, or $6. And if we look at our calculations here, we went from 36 to 30. Total revenue is $6, or profit is $6, or total revenue minus total cost. Okay, that's how you calculate it. That's how you run it. I have an FRQ graph on there as well, so you can check out drawing it from scratch and how to do that, and a couple of tips in that. Check out that video for that one. Let's do our losses here, see if we can get the same thing. So if we go down here to losses, MR equals MC is at 10, right? We see that right here. Find where MR equals MC, and that tells you everything you need to know, really. Now, I'm not going to charge this low price of 7. I'm going to dash all the way up until I hit the demand curve and dash over. So my price is going to be 9. So 9 times 10 is my total revenue, price times quantity. So 9 times 10 is going to be 90, right? Now I need to find my average total cost. So I take from that quantity, same quantity, dash all the way up until I find ATC right here. And dash over, and that is going to be 10. So my ATC is 10. My quantity is 10, so my costs are going to be 100, or this very large box. Total revenue is a small box. Total cost, sorry, I put a little dash there. Total cost is going to be the big box. My losses are going to be a distance between those two. Total revenue minus total cost. So this rectangle right here is going to represent my losses, or it's 1 times 10, or $10. So I have a loss of, or profit of -10, or a loss of 10. If we see that, total revenue 90 minus total cost 100 kicks out -10. Good to go. All right, a couple other questions. Question 1. Are monopolies efficient? Well, we have 2 ways to check that. We have allocative efficiency and productive efficiency. Are they allocatively efficient? The answer is no. Allocative efficiency means we're producing where MC equals D, or at the socially optimal quantity, where sneaky supply, which is MC, is equal to demand. So at this point right here. And you can see in both of these, sneaky supply and demand are at a quantity that is greater than where I'm actually at, right? Our social optimal quantity is higher than 10 in this losses graph, or than 6 in this profit graph. So we're not allocatively efficient. Are we productively efficient? Are we producing at the minimum ATC? Well, I can find my minimum ATC. It's where MC equals ATC. We know that intersection is at the lowest point of average total cost. Notice that quantity, still not where I'm at right now. Over here, MC equals ATC, way over here. Again, that quantity, still not where I'm at. So I'm not productively efficient either. So this begs the question, if we're not efficient, where's the deadweight loss? The deadweight loss is the distance between my profit maximizing quantity, my socially optimal quantity. My socially optimal is always going to be where MC equals demand, right there. Socially optimal where MC equals demand, right? Where sneaky supply equals demand. It's our equilibrium of the marketplace, if you will. Now, we're not producing there. We're producing at 10. This is the hatchet that cuts off the rest, the hatchet that cuts off the rest. So where is our deadweight loss? It is going to be this triangle to the right. It used to be a part of consumer and producer surplus, but now it is neither. That's how you find your deadweight loss, cut off by this quantity here, and the distance between that quantity and the socially optimal quantity at sneaky supply equals demand. All right, hopefully that was helpful. We'll stop this video right here.